Good evening, everybody. My name is, well, it's not the PhD, but that's the moniker I kind of run around in online and in places. My real name is John Heed Maneed. What I'm here to, talk to you about today is about how to compile fast, run faster, and scale forever when you want to have an external language that's built into your C++. And if you happen to choose Lua, then you're going to want to use the library that I built called Sol or Sol2. So I guess a little bit of history, because people keep always asking me this, so it'd be good to have a video that point people back to it. But why the PhD? So it's actually a promise on my future. I want to get a doctorate. I want to go all the way through the academic ladder, and that's kind of a promise I made to myself very early on. And I kind of fought for scholarships and stuff like that's going to help me to do that. I'm going to be finished my undergrad in about a year, and I'm kind of debating industry versus grad school. Kind of super leaning towards graduate school, but you know, I've got time to kind of be persuaded one way or the other. But it's not actually about like being a doctor. It actually stands for the Phantom Derp Storm. And it's because I'm really bad at video games. And so my friends, I had the moniker the PhD, and then my friends, we were playing games together, and like, you're so bad at this. And so they called me Derp or Derp Storm. And then, stuck Phantom in there to kind of fill it out. And then, there you go, the PhD. And so I'm terrible at video games, and that's what it means. But you guys know that, but nobody else is going to know that, at least not until the video comes out. So it'll be our secret. So what is Lua? Lua is a small scripting language used in tons of places. It's got databases, like Redis's database scripting language is Lua. The bunch of operating system components actually use Lua as a scripting language, which I didn't think they would do, but they totally do. Game projects, that's how Lua got super popular, right? I think it was Tim Schafer picked it up for Psychonauts or one of his older games, and he used it, and that galvanized the Lua's use in the games industry. And now there's a page on Wikipedia that you can just scroll forever about all the number of games that use it. Famously used for World of Warcraft and all that. It's also used in high-performance computing projects, which I didn't think people would do until I got an issue request from somebody asking me, how do I cite sol2 in a scientific journal? And I was like, why would you do that? And he's like, oh, I'm using this HBX project, and it's been great to me, and so I'm going to cite this in LuaJIT and talk about my project. I was like, wow, awesome. It's also used in GUI scripting, so Waze, OpenMPT, chat servers, server management. That was actually some of the stuff I worked on. I worked on a chat server that served 8,000 people at once from one machine. It was great. And we used Lua for that, and so on and so forth. So what is Sol2? It's a Lua to C++ binding library. It was started by Danny. His online handle is Raps. Last name starts with Y. He is actually a doctor. He's actually an oncologist. He does C++ for fun, but he's really good at it. So I'm pretty sure that if he decided to switch careers, he would just be just as rich and just as amazing, even as a doctor. But he started Sol, and he kind of got it up to a certain point and then kind of stopped with it. And then I found it and I picked it up. I didn't really have a project or anything I was using it for. I just liked the library, and I decided I'd go ham on it, so I did, and it turned into what it is now. So the library uses C++14 and better. Before it used to be C++11, but I was using Visual Studio back in those days, and C++11 Visual Studio in 2013-14 was nightmare. Eventually I kind of kept pushing it to be later and later as Visual Studio got better and better, and as I finally stopped getting less internal compiler errors and crashes and everything else. So it's written on top of the Lua C API, like most binding libraries are, and it provides a C API compatibility layer, and it has all these cool features that I'm going to talk about coming up. The library is established. As you just, heard from Marcel here, they use it in production. This is used in a lot of production places. I didn't believe it would actually be used in production in a lot of places, but it's actually used in the multiple arcade machine emulator. It's used for Chinese server farms. Don't ask me how I know that. And a bunch of other stuff. So Sol2 has actually become a library that's actually industry ready, which I didn't think I'd ever be able to say about one of my own I'm doing this for fun volunteer work libraries, but it's actually industry ready and being used in industry, and people come to me and they talk to me about it. It's kind of great. It's competed against 20 other libraries. So this is not Sol2 and Sol aren't the first libraries to do this. There's been a ton of other binding libraries in-house and out in the wild where people have created a binding library for Lua. And we managed to compete against those 20+ libraries, and we've kind of survived, and the other ones that used to be my main competitors have actually started to fall off a little bit, which I'm it's sad to see them go, but like on the other hand, it's like more market share, yes. So we're pretty much great in all respects except for the compilation speed, which is something I'm actually going to be dealing with, I guess, as I work on the framework more, focusing more on compilation speed and solving people's problems. We'll talk about some of those woes later. So we want to talk a little bit about the interface. What exactly would a good interface for Lua in C++ look like? And one of the things I want to talk about is I guess, language parity. Lua has all these constructs, like tables, strings, functions as like first-class citizens, and with closures and all of that. And of course, all has numbers and strings and all that kind of fun stuff. And so the idea here is that if you're going to embed a language in your other language, what you embed should look a lot like the language, your target scripting language, right? If you create something that uses different idioms, people who pick up, who come to your framework and want to get really far with Lua, and they know Lua very well, but they don't know your framework very well, if you use different idioms, it'll be very hard for them to pick up. So it's always good for your framework to kind of match the language that you are kind of trying to describe. And so I'm actually going to show you a little bit here. So hit this, and so this is actually some Lua code that I and some others wrote. You can see here you can have these tables here that are kind of initialized with like an open curly brace. You can index things with numbers. You have functions that can be like kind of namespaced. You can have and of course you can either declare on the top level, you can call them in the middle, or other things like that. And so this is kind of what your Lua code looks like, right? You have for loops here for your typical iterations, and obviously you have your if statements, your else statements, and all the other stuff that you can kind of do here. And I kind of have some other. This is kind of like a giant table that someone's making, right? So this is again, this is kind of just giving you the feel of what Lua looks like and all of that. And actually, I wonder if this builds. Let's actually run this so you gotta see, so you can see what people build with Lua and what I do. Okay, here. Whoops, but yeah, this is actually, and I think if I do this and I do this, oops. Let me just reset. Sorry, having two screens is like jarring in many, many ways. But yeah, so this is, right, went back to the wrong screen. So this is something that I kind of made quickly in Lua. And so it's just breakout, right? So you control paddles and all that, and you can fire off like balls and everything else, and you can get power-ups and the cool stuff like that. So, but these are the the kinds of things that you can make with Lua, and what the scripting language kind of affords you to get very far in doing that. So let's head back, and we're going to talk about. We're going to kind of get into more of the soul stuff. So again, what would it look like, right? So I showed you some Lua code, and so this is what the kind of the C++ would look like that would emulate this, right? We have this Lua object here. Right now, it's some representation of like our embedded language, of our VM, of our scripting language. And the idea is that as you saw in Lua, you could kind of index things by number or by string. So we kind of wanted to emulate that here, right? We should be able to pull out things like numbers. We should be able to pull out things like functions, all using the same syntax, because that's what, again, Lua supports. And we should also be able to call functions, functions that represent functions that came from the Lua virtual machine. We also want to be able to support this kind of idea of multiple returns, right? So in Lua, multiple returns is like native in the language, right? You can return 1, 2, 3, 4, 5, and do A, comma B, comma C, comma D, comma E, and you can just set that equal to each other, and you'll get 5 returns. So maybe emulate that a little bit of that magic over here by using like tuples or something, right? Pairs or tuples or other things like that. We also want to be able to set things, right? So you have a table, you want to be able to kind of build things into it, right? And here's another way, where you kind of make a new table and set it to the signals type, and then you index in that signals type and like set, like a lambda, right? A callable, right? That you want, either your Lua code or, through C++ through Lua and then back into C++ to call the code, right? You want that to be available. And then this is kind of just like a quick way of saying, hey, I want to run a script, right? That's just a string, right? So, and we just have a test here, if signal, then, access the signals array that we set here, go to the first index, and then, pass 20 into this thing, right? So this would call, this would say beep with 20 instead of taking the else branch, right? So this is kind of what this is kind of the ideal that we're looking for, right? It looks a lot, it looks like it's doable in C++. It's very much reminiscent of the syntax that comes from Lua. So a person who is kind of just mucking around a little bit will still be able to get pretty far traction even if they don't quite read the docs, right? They just see like a quick example and then they start trying to do stuff. We want them to kind of do stuff and have that do stuff that they do work. So let's I guess talk about how we make this happen. So we're going to talk about I guess, the pinching point here, or I guess the place where we focus all of our effort into making this happen. Stacks. Lua's C API is stack-based. When you work with the C API, you have to push things onto its stack, push any other operands you want to a stack, call a function that does some operation, and then you get back a result on the stack or something else, right? It is annoying to manage even when you understand it. The other thing about it is that it defines interrupts for all of its primitive types, and then it provides, like these two things for custom types. So it has primitives for numbers and integers if you use a late enough version of Lua, strings, tables, functions, and then you can go all the way to complex entities and custom types like user data, light user data, and I'll kind of explain what those terms mean a little bit later. So it's good to use for simple things, right? If you want to use a C API, and I have an example of like what the steps you would use in the C API to make this like make this Lua code happen in C or C++, right? So you want to get my table and you want to get the value A out of it, right? So you use Lua get global to get a global variable out into your stack. So this time we're asked for my table because that's what we're asked for here. We use get field to say get the A field at -1, and -1 in here is just counts from the top of the stack down. So when you use negative numbers, we're saying the table on the top of the stack, get A out of it, right? And so that's what we're doing. And then you retrieve the value out of that thing that's left on the stack now. So there's this thing that we got out of the stack that represents my table and index into my table with A, and then we use Lua to something to get the number, user data, string, whatever it is. And so that's not too difficult, right? It's three functions you have to call to kind of get a value out of Lua, minus some Lua pops for cleaning up your stack. Same thing here for calling a function with parameter 2. We get the global and we put it on top of the stack. We push a number on top of that, and then we use this thing called Lua P call, which takes the number of arguments and where it is on the stack, and then calls basically pops all of your arguments off the stack, and then where the function is, it calls that function. And then of course, when it returns, it fills your stack with whatever return values, right? So you use Lua2x again, like you do here, to get your numbers, your user data, your strings, your whatever, your tables. And then you use Lua pop to, get rid of everything after you've inspected it or messed with it or done whatever you want with it. And so again, this isn't too hard, right? Not too complicated. Then you want to do this. So you want to call a function with the result of doubly indexing into my table, and you also want to use another parameter that is the result of my func2. This is a nightmare to do in the Lua C API. This doesn't scale. It's an absolute nightmare to make happen and make work. It just doesn't get anywhere. So it kind of wastes your time as far as developing boilerplate for it, and it wastes your time as a developer because who wants to figure out the C API calls to make that happen and arrange your stack nicely. So we want to wrap that up, right? And even if we didn't present this stuff to the user, I needed this for my sanity when developing this because I wouldn't be able to handle it otherwise. So I developed these kind of 4 or 5 functions here. The most important, I guess, are the top 4. So we have sol stack get, where we give it L, we give it an index, and this record type here, where it kind of keeps track of what we're doing with the stack. And so what this does is this returns a type that something related to or analogous to the type here that we pass in the template parameter. And so this will allow us to get type out of the stack, right? At some index, right? For some definition of whatever that means. Then we have push here where we give it the state that we have and anything, right? So, we throw in a number, we throw in a Boolean, we throw in a string, we throw in, our own custom struct, whatever it is. This pushes it into Lua, right? That's its job. And it returns to us, I guess, the number of things that we pushed onto the stack, right? So this helps us, kind of keep things clean and everything. We also have a check method, and this is kind of for safety, right? Before we do a get, we kind of want to check that the thing that we're getting is like what we want, right? Because Lua is a dynamic language, and we're interacting with the C API. It's got to be what we want it to be. Otherwise, Lua will more than happily let you alias and UB your way into a crash. So you could call Lua to string on something that's not a string, and it'll just hand you a null pointer, and then you go use it and it explodes, and well, that's that. So you need a checker to kind of like verify safety. And then we have a check get here. This isn't really like a special thing. This is an optimization. Its default implementation is just to call check, and if it succeeds, then call get. Sometimes the Lua C API functions kind of conflate both. So if you do like Lua to number to get a number out of Lua, it will give you it also has an out parameter for that basically tells you this is a number or it isn't, right? So there's some optimization potentials here. So if you're doing the check, we don't want to individually do the check, get the result, discard the result, and then do a get again where we actually get the result, right? That's a waste. So this is just more or less an optimization. And the handler parameters here is like a panic handler that we call if we do a check and it's wrong, then we just call your handler, right? And so this allows you to kind of, if you're using this low-level API, this allows you to insert your own kind of error handling, right? So you want to throw, you can throw. You want to standard terminate, you can terminate. Stuff like that. And of course, you don't have to pass all of these. So we default like things like the record and the handler. We default that for you, so you don't have to worry about it. But if you do, you have access to it. And this final one here is a stack Lua call. And what this does is you pass it some type of callable from C++, or some type of invocable is the standard Ease term. And you can extra arguments that you want to tack to it. And basically what this does is it pulls arguments from the stack in Lua, gets them all in the right place, and then calls your CPP callable, your invocable, with the things you just pulled off the stack, right? So we do some magic here to make sure that CPP callable, to like inspect CPP callable and get all of its arguments and like call it correctly. And we do it for member variables, we do it for member functions. There's a big list of like bind traits and everything we have to do to get all the arguments and do some crazy stuff. But that's not, that's kind of a too gross of an implementation detail. And also we have these fixed interrupt points, right? So on top of having these functions here, all these functions kind of are defined in terms of this thing. And you'll see that they're basically just structs. And so we have getter, pusher, checker, and check getter, right? They correspond to the function names. They each have a .get, .push, .check, and .checkGet. They're all usually implemented as static, but we always access them as a member function, as if there were a member function on this, like after we create one of these structs, mostly because you are allowed to override this struct with your own specialization. And so, if you wanted to do some kind of stateful thing or whatever, we let you do that. So we don't do : get as a static, we do .get. But it doesn't really matter as far as performance goes, because if you can access a static member function or a static function on a class using the syntax, and the optimizer will just know that it's a static function. It won't do any crazy. It won't force you to go through the member syntax or anything like that. And so Lua, as you can imagine, Lua call uses basically all of these to get the arguments from the Lua stack and put them in the right order for your CP callable, and then call the thing. So these are the interrupt points that we defined. And they're very useful because scalability kind of requires some of these defaults. So C++ has a lot more than integers, floating point strings, functions, and table alikes, right? So you can create infinitely many types in C++, and you need to have a way that those map into Lua in some kind of sane defaulted way. And so for any user-defined type T, we kind of treat this as what's called a user data, which is just a blob of memory that Lua associates some semantics with. And user data will come more in handy as we start talking about metatables and ways to override the behavior of your object in a Lua script. So some types are special. For example, I showed you that that like idealized code example in the beginning with that had tuple and things like that. We specialize the getter for things like tuple and pair, so that if there's multiple returns, we kind of allow you to not only push multiple returns into Lua so that it comes out in the ABC syntax, right? So if you return a standard tuple, we automatically unpack it into ABC into Lua so that you can access each of the things. And you do the same thing for pairs and those things as well. We also have ways to mess with vector, list, and map, and all the other C++ containers. So there's two ways of kind of handling these. There's the expensive convert to table way, and then there's the way where we store it as a user data, and then we kind of like set up this meta table where we make it feel like a table, even though it's not in Lua. And so ultimately, we actually chose the second option here because it's direct, it's faster. It plays a little less nicely with the Lua ecosystem, but later versions of Lua introduced like nice, basically overrides and niceness into the system. So this is only a problem if you're using like Lua, an older version of Lua that came out in like 2005, like Lua 5.1. Which you would be surprised how many people actually use that. It's never going to die, and it's very sad, but we have to deal with it. Also, we have these special strings from the standard W string, U16 string, U32 string. Of course, unsurprisingly, people want these types to work. This is especially, I get a lot of issue requests, especially for people who work with Win32, and they obviously want either U16 and W strings, so they can interact with the Windows API. So we do conversions on the fly for these, and Lua stores most of its strings as UTF-8. So we kind of do conversions at the boundaries every time you pull out one of these or every time you push one of these in. And there's some optimizations we do for that, but we won't talk about those. It's basically just we have a big static buffer that we use, and it's great. So this is essentially what we're doing, right? There's all this land in C++ and there's all this land in Lua, but we're shrinking it down, we're pinching it down. Everything goes through this box. Everything has to go through a get or check get or push, or use Lua call. So it's very uniform and it's based on type. So it's very easy to reason about, right? If you're returning some type from a function, you know that you're going to call get. You know where it's going to hit in the specializations. So it's very easy to reason about. This is the behavior that this thing will have when I return it from my C++ function into Lua, and this is the behavior my thing will have when I stuff it into Lua from like a C++ function or something, right? And so now I kind of talked about some of the low-level stuff. So now we want to go higher than that, right? We need higher-level abstractions because still people calling that stack API just isn't good enough. So we built something called sol reference. And so basically this is our rule of zero type for Lua bindings. And so the rule of zero was a term coined by R. Martinho Fernandez, who actually was in the lounge. I spoke about the lounge C++ place I visited. He was from there, and he actually coined this term, and he made a blog post on Flaming Danger Zone, which is his blog. And it actually got picked up by Scott Myers. There's a book and all that, and it was great and wonderful. But basically, the rule of zero here is that we have a reference counting object for something that is taken from Lua. And it's stored in the Lua registry, which is kind of this heap of memory that Lua allocates for you to keep Lua objects alive. It's a little bit slower than working with the stack, obviously, because you're taking the thing off the stack and putting it in this like heap in this pre-allocated heap memory. But it is still pretty fast. And it's also faster than kind of performing serialization and all the other stuff. And so it's basically a Lua-specific version of standard retain pointer, which is a up-and-coming like reference counting control block type for managing these things. That's being proposed actually. I think it's actually it's going to come in the new RapperSol mailing list as well. So if you're interested in that kind of, if you're interested in an easy abstraction, so you don't have to kind of do this by yourself, which is, I'm very interested because I don't want to keep implementing this thing over and over again when somebody else can do all the work for me. That's the proposal number right there. So here's our formula for success when we want to create some of our abstractions, right? We derive from sol reference because it's our rule of zero, it's our RAII type, right? We don't really add any data members, we just add functionality and type safety, and after that, we profit. So literally all of these abstractions that we have here are built on top of sol reference. So we have objects, we have tables, we have functions, threads, coroutines, state view, and state. All of this built on top of this kind of, all of these abstractions that we have. And there's no like special data members or extra invariants we have to bookkeep here. Everything comes from sol reference. And so all we have to do is we just kind of add member functions that do what people want us to do, right? So we have an is checker that allows us to check if the type for this object is a T, and with an as that does a conversion for us if we want it. We have table, which does operator access indexing. We have functions that override the operator call for calling in C++. We have threads that encapsulate a Lua thread, which isn't actually like a C++ thread. It's just like separate stack space so you can run your coroutines on them. That's what those are. We have coroutines, which again are these ideas of like functions that you can kind of yield and pause and continue and stuff like that. We have state view, which isn't exactly derived from sol reference, but it keeps some sol tables on the inside, so we have easy access to the registry and globals. So anytime you see that like Lua open bracket and like a string to get something, that's using this. That's using this here, where we go to the global table when they do that syntax, and we start basically doing the operations that they want. Yes.
Is state view mutable?
Yes, everything about Lua is mutable. So state view is probably the wrong word, but I don't think state spam was a good word for it either. So state view kind of encapsulated more or less what I wanted to say about it. It's kind of a cheap look at the state, and it's again, state ref actually might have been a better term, but I am 3 years into using this, and breaking changes are difficult. Though actually sol3 will have some breaking changes in it, so I might just like break everybody all at once. Yes?
Is your object kind of like standard ini underneath, like you can literally hold anything?
Yeah, it can literally hold anything, and so it can even hold like nothing. And so you can do is and as checks to kind of do that. And so this is useful for APIs where you see, because again, C++ is a very statically typed language, right? So say you have a branch and you want to return a string in one case or a number in the other, right? Well, if you return a sol object, you can construct the object. It'll put in this nice, type arrays container that's mimicked in Lua, and it'll just get pushed right into Lua, and everything will be very safe and nice and happy. And so that's what object is, right? It's this kind of type arrays generic any object that for anything that comes from Lua. Yeah.
Have you gone to the level of doing like small object optimization kind of thing?
Oh no. So when we store these things, it's ephemeral, right? So when you store something or get something as an object, we're always doing the serialization to and from the type. And that sounds terrible. I know it sounds terrible to start, but there are some things that I'm going to show you later about how we mitigate that and make it so that that's not a problem. Yeah. So don't worry. Yes?
When you said that it's a type erased wrapper, did you mean that it behaves like a value type in C++? Like if you copy it, it actually copies in a non-aliasing way?
Yes, so it does copy. So the thing about sol object and the sol reference that kind of backs it, it's a reference counter plus like the state that it comes from, and that's it.
So these all things have reference semantics.
Yeah, all these things have complete reference semantics, right? So you copy them, it bumps up the. That's why I said it's like retain pointer. I should have explained what retain pointer was. You copy it, it bumps up the reference count. You destruct it, it decrements the reference count. You move it, it moves, it steals the guts, that kind of stuff, right? So
it's more like an object ref instead of an object.
Yeah.
Yeah. Okay. That's fine. I just wanted to know.
Yeah. Just making that I guess specific. All right. So these are kind of the base things, and now we're going to talk about the magical abstraction that we kind of sprinkle on top of this, right? All the fun stuff that really makes sol2 feel like sol2. So tables in the proxy operator, right? So we want to index into a table, Bark and Wolf, right? And we want to access my table. And so we define this operator, and what we do is we basically keep perpetually creating a proxy type every time you access it. So we take the key, we store the key that you gave us. In the case of like a C string, we store like a const char pointer. And we basically have a rolling perpetual like standard tuple kind of type that just keeps storing more and more keys as you go along. And so one of the things I guess I want to mention here is that my table here can represent multiple things. So for example, we have like state view and state here, which kind of have the globals in the registry. So there are some additional optimization we can get here because this Lua C API has different calls for like getting it out of global and like generically accessing a table. And those have different performance characteristics. In fact, there's a wide performance characteristic gap. And so picking the right one or the wrong one changes the performance characteristics, but it does give you the same result, right? You can act, so there's basically two ways to do certain things in Lua. And so it kind of just like, it's an API trap by the C API, right? If you're getting globals, and if you're getting a global, but you go through like the slow, push the global table on the stack, get access to the table on the stack, and then get your value, it's a lot slower than saying get global in this thing. So it's a bit of an API trap in that sense, right? That Lua pushed that, Lua C API pushed that kind of burden on you to implement and make sure that's fast, rather than handling it themselves. So we have to kind of account for that when we do these kinds of crazy indexing things. So operator, as I kind of said before, it lazily concatenates and saves keys, generating a new proxy type. And it's basically one tuple entry per operator access lookup. And so kind of as an example down here, we do woof, bark, and one. And so the actual type for this is like a proxy of a global table with a const that gets accessed by a const car, another const car, and an integer. So it's basically super lazy all the way, right? It's almost like expression templates, but kind of not really. And the only time we commit anything is when you actually like try to inspect the value. So if you say double value equals X, then we do a get and we pull out the value of a double, right? Or if you set it and you say we set it to the string, then we do the full get the table, and then write into the last table, right into the bark table at index 1 with the value woof, right? Okay, does that make sense? Yes.
Is the conversion operator explicit or implicit? That's what I was just going to ask.
Everything's implicit. The reason I chose to do this implicitly is because it's nicer, and that's literally the only reason. If we make it explicit, then people have to do .get. I mean, there are .get and .add, so you can be explicit if you really want to. But I found that.
Would still work.
What?
Double value would still work if it's a double, right?
What do you mean?
Explicit conversion operators, right? It would still work.
I'm sorry. So when you were making, I'm sorry. So the question was, if you have are these operators marked explicit, right? So I accidentally interpret that question as, do I force people to explicitly like access a thing? No. So I don't mark any of the operators as explicit. No. Which again, I don't think I necessarily need to, and it hasn't really cost me much to not. I haven't really looked into the design where I do qualify my conversion operators with explicit. I might have to look into that later, but this is kind of the design I kind of rolled with. Yes?
Is this laziness, when you're writing in Lua, does it do that? Or is that just something that you're doing? Like,
this is something I'm doing on my own to kind of give the appearance.
Lua is not lazy this way.
Yeah, Lua isn't lazy this way. It will, if you say, if you ask for woof and bark, it will get woof and bark immediately. But the thing here is that I kind of, this laziness becomes necessary, and I'll kind of show why it becomes necessary when we start talking about safety and stuff. Yes?
Does this mean that you're accessing the table under woof and then a separate table under bark and then a separate table under one, or do Lua tables just sort of flatten?
I'm maxing separate tables each time.
Okay.
So I have to dig into each table every time. So yeah, that's kind of what that's about. So does everybody understand this?
Yeah,
good?
there's an alternate design that you could literally construct a woof.bark.one key, and
right.
that would be in the same table, which would also make sense. And
right.
I was wondering if that's what you were doing.
Right. So there are actually other libraries that, and so the question was, the comment was that I could like do something like construct like a woof.bark.one as far as like an accessor syntax. But there are other libraries that do that, and it actually costs them because Lua doesn't actually understand that syntax when you pass like a string to get something. So it costs you to do the parsing on that yourself. So it's sort of, and when I show you the benchmarks, I think I'll be able to point out which frameworks kind of do that and why it explodes. So actually, I'm going to kind of show you, I guess, a little bit of the, that is not the button I wanted to press, show you a little bit of the code here for a proxy. Oh man, I need to take this over here because I can't see. There we go. And we need to go here and here. So the proxy type, as we have it, and everybody can read this, can see this?
Yeah.
The main bit.
Yeah, the license. So we actually have this kind of, these are again implicit conversion operators, and we kind of have this like all this SFINA and stuff going on here for these various different kinds of types. And so it looks, again, the SFINA goes on for a while, right? There's a lot of checking if it's a primitive, if it's not a string constructible, stuff like that. And then we have to kind of have opposite conditions so we can have both these exist in the same space without exploding. And it's very complicated. So I'm going to kind of spend a little bit of time explaining why we have to do that looniness with the types. Okay, I didn't go backwards. So let's, I guess, kind of break it down. So what was all that for? So here's a simple case, right, for kind of enabling this magic conversion abstraction. This is an int proxy, right? And we have an implicit conversion operator to int. And this is the syntax you use, and this just automatically dumps out integer whenever you kind of check it, right? If you try to convert to like a const char star or something, right, it'll just, get an error. We can't convert to this type, right? So with that in mind, we decided to make a unicorn proxy, this magical proxy type that just we run any arbitrary code in here, and we just return whatever we need, right? That's just what we want. So we get these integers, and we get and we can have a const char star here, and all this converts, and it's great and happy, yay. There is a pitfall with this though, and the pitfall that destroys our unicorn, poor unicorn, is things like stood tie. And that value shouldn't be there. But things like stood tie. And it explodes because when you try to return something that has references inside of it, that doesn't you can't propagate that past, you can't propagate that past outside of this operator t here. So if you have a standard tuple of an int ref and an int ref, you can't construct that standard tuple with an int ref and int ref and then return it properly to this, right? Standard tie kind of works on the assumption that you're going to return a tuple that has a bunch of value types in it, and it will just individually it'll each individually assign through each element of the tuple to the other, and that's how you kind of get that magical standard tie multiple return type thing. This fails this, and this causes us a lot of problems that we have to kind of get around in magical ways.
Structured bindings would have a similar problem.
Yes, the structured bindings also have the same problem, and it drives me up the wall, and I can't fix it because the language literally doesn't let me fix it. So I actually, yeah, that's fixed slide, yes.
Do you do one of those wacky do your own get things to get around it, or?
Sort of. So you're right. So actually, I mean, you wouldn't, but I would. So
no, because you couldn't return at compile time how many elements there would be.
Right, and so that's part of the problem. So you have to write your own tie and your own get, or you have to write your own get that you then default to the standard tuple one, so you don't waste implementation time trying to re-implement all of that. But yeah, so this explodes horribly. And so the left-hand side is basically it rules. It's supreme over all that, right? So the implicit converter take the left-hand side as it is exactly, right? So it'll preserve all the references. It'll preserve whatever is in your tuple or whatever else, right? And you can't really change that. And so again, like I said, you can't return a reference to something that's not already living in memory, right? So if you try to create a, Lua returns its numbers and things like that as values, right? So I can't take a reference to an integer that Lua's giving, the C API hands me as a value, right? Yes.
Oh, never mind. I just figured it out.
Okay. Yeah. Also, so you cannot SFINA or change the return type in its fullness, right? So the type T that you see on the operator on this is special. You can't wrap it. You can't put special code around here to change what this returns. It always goes to a return type, to what's on the left hand side. But you can do a little bit of change based on T, T reference and T and T as just a value. So you can make a difference between choosing between a reference and a value. And you can also, if you do enough SFINA, like I showed you in that complicated piece of code, you can kind of disqualify certain things entirely, right? So I had my own conversion operator for standard string at the top, and that was because if you put a standard string here, it would choke up completely because it would say that, oh, I need to construct a standard string from these multiple constructors I have. Well, const char star is a good match, so is standard string, so is this other thing, so is this other thing, and so it'll just blow up on you because it just can't figure out what the overload is. So that's why I had to, not only did I have to have is primitive checks and all of that, but I also had to say is string constructible as part of the substitution failure is not an error stuff I was doing. Does that make sense to everybody? Yeah. Okay.
So even though, you might be getting ready to go into this, but even though the unicorns don't work with things like structured bindings, you could still do a static cast of the thing and implicitly invoke your
Yes, and so that's actually the advice I gave people, like just static cast like standard tuple or whatever they needed, and then it would sort of work. But again, that's not very expressive and all that fun stuff, right? We're going for magic here. That's what we're here for. So,
I mean, have an unpack method if
right. So and we do have that thing, right? But I think one of the things I actually think I'm going to propose to the standard soon is the ability to have your own return type, right? So T will be reduced as it always is from the left-hand side, but then you can insert like a type here that would say like return this, even though you're asking for this expression, I'm going to return like an integer anyway, right? Yeah, I'm not sure. And this, see, because I had this idea like 3 years ago. I'm not sure how well it'll fly, but again, I'm a little hopeful because this is like completely opt-in, right? Like this wouldn't compile right now, right?
It will not fly
I really
because
want to know Steven's opinion because he just raised his hand that he doesn't.
Yeah, you can make it work.
Yeah, I mean
I'm just really worried that it will cause things to break in unexpected ways
well,
when you use it.
right. So I think, but the thing is that this isn't like valid syntax now, so it won't break. I know it won't break old code is my idea, but it might have funky interactions when you use it like in the new. Yes.
Yeah, it'll work a little bit like operator arrow does now.
Well,
it
okay.
ends up chaining.
Right. So the idea is that I would if you did have this case where you had standard tie, I could change the return. I could specifically like decay or unqualify each of the individual tuple elements, and then return my own tuple that is exactly what standard tie or structured binding would expect. Yeah.
I am not entirely sure that's the case because the whole point of operator T is that you find the function that gives you a return type of T. If you don't have one, no template will match. Like you will just spin out and do nothing. Like
We changed our idea of the intent of it.
Yeah.
That operator T becomes the function that will give me something convertible
Yeah,
to T.
it's convertible. It's a convertible operator.
Right. So-
how do you kill deductions? Like how do you select the most?
We don't have to solve this.
Yeah. Yeah. Right. So
If you can like
for-
5 different functions that
so
all
for-
print and they're all the same.
for the video that we're watching, I guess right now, we're kind of bike shedding if how effective this would be, and so I think that this would be a great conversation to have, but we'll have to have it like after because I need to.
Right.
I got a lot of slides. I got a lot of slides.
We're not going to get through that.
Yeah. So the other thing, right, is that the other kind of proxy that we have is like a function result, right? It's just this type. It's another kind of proxy that has the same issues, so you can't standard tie and all that stuff, right? So again, we have standard tie here. We try to call this function, and of course, we have this int ref return that just explodes. So we have a sol tie here that kind of changes a little bit of the semantics, right? But does the right thing, and so it has custom expansion as an customized operator equal. So it assigns properly, and all the A and B get updated properly. So that's kind of my answer to standard tie right now. So I mean, I did like Lisa had mentioned before. I kind of did go the hacky terrible route. I don't know. I kind of like doing this stuff, so why not? So user types. User types are things, are basically everything that's not currently recognized by the system, right? So number, strings, functions, and all of that, like std function, all of that have like getters and pushers and all of that correspond to their Lua types, right? Then there's this badlands basically of user data where you can do whatever you want with them. And so what I decided is I was going to map all structs that weren't implicitly convertible down into this kind of like special thing. So for that, I actually have a demo. So I can actually read this now. So close. There we go. So here I'm going to just kind of give you a crash course in the library, right? We have checked this sol check arbitrance thing is just for safety. So you define it and you get all the safety forever and ever. IO streams because we're going to be printing stuff, and then we have the struct ship, right? And we got bullets, we got life. This is like gamey kind of thing, gamey kind of example, right? Because people need these because if I don't have them, they'll be very confused and ask me why my thing isn't game friendly. But here, so we have a function to hurt if we get hurt, and we have a boolean that says if we shoot. So if we have bullets, we shoot and we turn true because we shot stuff, and if not, we can't shoot. It's false, and it's horrible. And so these, I have like a million of these examples, and this all goes in the documentation. This is actually, all of this actually gets compiled as part of my CI. So my examples and my tutorials and everything else always have to compile, and if they don't, then my build fails, and everybody gets to see the big red tag that says my build is failing, and I feel ashamed for a little bit until I go fix it. So here's the sol state thing I was talking about, and so we just call it Lua like we have in all of our slides. And we open some libraries, we open the base library because we want to print stuff and stuff like that. And so here's the introduction of a thing called a user type, right? We say new user type, we give it the class that we're making, and we give it a name that we want it to show up in Lua, right? So when we program in Lua, ship will be the kind of anchorage type that represents our ship class. And what you can do is you just kind of directly pass a bunch of stuff, right? So you can pass member variables or member functions, and you can pass member variables and other things like that. And so this is kind of very lightweight, right? One of the things you'll notice here, though, is that there's no like curly braces around like these pairs, right? And this is kind of a bad design thing that I needed to do in the beginning, but turned out to be a very bad idea as far as scaling up went. Because what this basically is a massive variadic like template, right? And I do all kinds of crazy stuff with it. And so this is actually one of the biggest sources of compiler pain, because I wrote this in first and I wasn't really doing anything crazy with it. I was like, oh, I made a little ship, and I made a small toy program. And then people come along and they bind 250, 500 members with this thing, and it goes like, they have this massive variadic template that's like, it can't even fit in their debug info anymore. And the compiler is like dying trying to compile it all. It manages to, and when they run it, it's super fast. That's great, but it's this massive kind of thing that kind of doesn't scale very well as far as compiler time, right? So this was a great idea to get off the ground, not a great idea to stick with. And this is actually one of the primary things I have to change for sol3. Yes.
What is your metaprogramming under the hood behind this look like? Because just a variadic template of 1,000 types is still going to be pretty fast as long as you're not doing anything with it.
So here's the kicker. When this all gets down to the base of it, so I pass this through like at least 3 functions. So there's at least 3, 4, 5 functions that have all these types in it, all 1,000 types in it. So that's bad. Then I do a gravesend and I pack it all into a tuple. So I have a tuple of 1,000 elements, and that just kills everything.
It's actually going to kill you on GCC.
Yes, exactly. And that's where I get a lot of my bug reports. Some for MFCC, but compilers nowadays actually better at handling this, and so nobody so far has had to, on later compilers, nobody's had to specify f template depth like 2048 or whatever. That was kind of it. But to kind of show, and that's kind of an alternate way of doing it, where it's still a variadic template, and you pack it into this type, and then you just set the user type. It's the same thing. This is what the code looks like, though. So we automatically create a new member for your constructor. If you have a default constructor, we automatically bake this thing in for you. We can call member functions, so we use this colon syntax in Lua to call that. And basically, what it kind of destructures into is dot shoot, and then it calls it with basically the member that you put the colon on. And so that's actually, oh god, it made the string. But in Lua, the colon here is syntactic sugar that basically just turns into this. And so that's kind of how they mock up member functions in their language. So it's kind of like, it's sort of like it's just sugar, and everything kind of goes through this syntax, and so it's kind of like a universal call syntax of a way of handling it. Let me get this out of the way. You can also, so you can call these member functions, and you can also access member variables like you would kind of expect. And so you can print out these things and set them and change them and all that kind of stuff, right? So if we compile this, it should totally work and not break, and I won't feel bad, I hope. I should have a breakpoint here so it doesn't like exit immediately. Yeah, it might be too, I was too fast. Okay, let's do this again. And you can see it still takes a while to compile, even though I've already pre-compiled it. The horror. So yeah, right, the window showed up here because this duplicate display. And it's very tiny, but you can see here that it prints out that we're not dead because we have life. We have 80 life left, and we have this many. We have that many bullets left. So basically, this is all this. We take care of doing all the binding and stuff underneath, and so you can kind of just set types to have these properties on them. And there's other crazy things that we do beyond just setting user types and everything. We get really, really creative with it. So if I could show, that's not it at all the way down. Oh no, this is not these examples. These are the examples. And so we actually have some very crazy examples that we do here. So for example, you can actually bind bit fields to sol2 on a type. And what we do this by using functions, and we have this thing called sol property, where you can basically use functions to behave like variables. And so in this case, what we do is we have a structure up top here that is basically a bunch of bits. We basically allow you to set those bits by using, we created some bit library that basically does reads and writes with a function, and then we pack that into a property. And so every time you access some of the stuff on these classes, it correctly, it uses the function to put things in the bit field, but you can access them in Lua like they're a variable. And this was actually very important because the first time I actually figured out that the multiple arcade machine emulator was using my code was when I got not a pull request, but an issue request about I can't bind bit fields to these low-level arcade memory things that we're using. And I was like, why are you trying to bind bit fields? And they said, oh, we're using this for multiple arcade machine emulator. Like, oh, this really is kind of taking on a life of its own. So actually, I made this example to show them how to do it, and then I put this in my examples. And so a lot of the examples you see here actually kind of came from people who had issue requests and said, I want to use this feature, I want to do this crazy thing. And so I kind of showed them how to do it. And so again, we have all these there's a bunch of other things that you could do with, user types and crazy things. You can have initializers, you can have factories that you can create your own custom destructors and all sorts of stuff, and it always obeys RAI. You can bind smart pointers and other things like that, and we do a lot of crazy stuff. And it's all powered by a lot of template stuff with tuples and all of that, and it gets a little bit expensive in the background, which is why I kind of have to figure out how to fix it all for sol3, but that's kind of some of the stuff we do. I believe Shift F5, there we go. So that's kind of what user types are and how we kind of handle them. And just as an aside, you can take a struct that you haven't bound as a user type and stuff it into Lua, and we'll kind of losslessly transport it through the system for you. So you don't actually have to register every single type you're going to pass into sol2. You can just kind of use things you can just use it as a transport layer as a blob. And the funny thing, and the great thing is that if you use it as a blob and you're using it as a blob for 30 minutes down the line, you can say, you know what, I want this as a user type, and you can register as a user type, and the blobs from before will pick up all the stuff that you registered. And so it'll become immediately usable like a real user type, which is useful for if you want to do things like, have a type that's available only for this duration of this function, and you kind of imbue it with these properties, and then when your user is done using it, you kind of rip out all the properties on it. And so this kind of lets people do things like sandboxing and safety and things like that. Overloading. So we do actually allow overloading in sol2. Sort of was a bad idea when I started doing it because I didn't realize how hard it would be or what it would cost me. And so, and then it's famously, apparently, a lot of language designers who work on C# and stuff like that, they always tweet about getting the language right is 5% of the work, but overloading to the rest of the 90 to do to get right. Actually, I remember when I was doing an internship. I had an internship at Microsoft, and STL showed me a little bit of the code for the compiler, and he showed me the dimto.c file, which is did you mean that one? And it was a million. I'm pretty sure that source file was over 50,000 lines of just the compiler hammering away at conversions and everything to figure out what did you actually mean for overloading and everything. It's nuts. And then I decided I want some of that in my life, so I implemented overloading. Oh boy! So here's some quick code, right? They're all just declarations, except for this one. This is the definition. And I decided that I would allow this syntax, right? So sol overload, bark woof, bork, borf, yip. And I have to pick and so you can, give me this call. You say my class.new, true, and I'm supposed to pick the right one out of all these. And I have to do it fast, because if it's not fast, then people will use it and then complain about it, and people did. So I came up with something that is not the fastest. I know there's faster, but we're gonna simulate this, right? So they call f my class.new and true. and it must match my class reference and bool, and it has an arity of 2, right? This is what I gotta work with. So first up, we're just gonna do a linear scan, right? Bark, right? It's got an arity of 1. This isn't what we want, right? Next, we kill everything that has an arity of 1. Because we passed in everything in this, and because all the signatures are compile time signatures, I know all of these args at compile time. So even though I do a runtime check to check for arity, I pass in to a standard integer sequence that the arity from this, which is the compile time value, shouldn't be allowed anymore. So I'm basically creating a compile time tree through recursive function calls of things I don't want. So immediately I strike out this and this. So I don't do any testing on it. I don't test its arity. I don't test the number, its arguments for anything like that. So it just immediately gets stricken out. So that's a massive improvement to time. Does anyone have a question? Okay, yeah, Jason's disagreeing with me, which is great. We also do this for arity of 4. And so because we know arity at a compile time, we can immediately knock that out too. But I mean, there's no more of arity 4 here, but if there were, we would just kind of call them right out. Now we have something that matches the arity. And so really the only thing that we actually do start checking types on are things that matches the arity, right? So this drastically decreases the amount of like, are you this, 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 that we're doing. So this has 2 arguments, it matches what we want, and it's great. We picked this one. And so that's how we kind of go through and do our overloading. Any questions about that? That makes sense? Great. So there's some other things we could do here. Like, so for example, there might be multiple ones that have 2 arguments that don't match this exactly, and only one of them does. So what we could do is, because we know the arguments at compile time of this function yip, what I could do is I could also create like a rolling list of like types that we've successfully checked. And so anything that matches, I could just skip doing that for like later checks, right? But that's an amount of template, shenanigans I'm not quite willing to commit to just yet. Right, so now question, yes?
If you have ambiguity, do you get a compile time error?
No, we do first matching, which is, it has its benefits and has drawbacks. So first matching allows us to do things like you're able to have a fallback function. So I have a type called sol variadic args, and so basically that just sucks up everything, right? And you can, and it has some other features as well. So if you push that as the last one and nothing matches and you get to that last one, that'll just kind of match, right? And so it would, technically it's an ambiguity if you take that function and you put it in the list first, that one will always match, right? So technically that's there are better matches, but we don't commit to like a full, compile time, these are all this is in a completely disjoint set of types, right? Yes.
The functions that you pass in,
yes.
If they have default parameters, do they count as like a range of arities?
Oh no, that just breaks.
It's possible to do. You could just test it in
But you
CA
can't-
context.
You can't get a
In
pointer.
this context, you can't detect.
But
Yeah,
you
yeah.
can call the pointer in a non-evaluated context with one less argument and check. You can do this.
I mean, so yes, you can do that, and you can. So what Odin recommended was that if this one of these, or sorry, he didn't recommend it. He tempted me with the possibility that if this was int arg equals 0, then this could count as arity of having 0 or 1. And this issue request has come up a bunch of times, and I. Yes.
Yeah, okay, next time a user asks me this, I'm saying it's not possible to.
Right, so Jason said he's going to tell the user it's not possible.
Given this API, it isn't possible. Because by the time you get into standard overload, you already just have a pointer.
Well, no, but you could take that pointer and then check if it's CNAs when passing it.
No, you. I don't think you can do that with the function pointer, right? You would need the name of the thing, but yeah. So by the time you have a function pointer, it has a type and it's hard coded that it takes 2 things, right? It's lost its default. You can't figure out the default arguments anymore.
No, but if I have a function, if I have a pointer to a.
But overload could take something that's not a function pointer that like.
Yeah, so if it's a class type, right, and and in that case, right, you could check its operator equal, you could check its colon operator call, and then start checking those things. Right, but you can't do it with a function pointer because the type's already baked in by the time you get here. And if it wasn't baked in, you would have to resolve it. Otherwise, there would be a compiler error here, right? So that's just part of the problem. Yes, Lisa.
So this is more, well, for everybody, I guess. I'm wondering if there's a way to do a template that creates a class context with one function in an overload set corresponding to each one of these things, and just resolve it by C++ rules.
Right. It is, but you'd have to do it for every possible Lua type you would be passing in, and you can't enumerate those in general.
Yeah. So because Lua is a very strictly runtime system, right, you'd have to still enumerate all the types, and you wouldn't be able to kind of forward. But that's sort of what we're getting at with this, right? You know, if I did the recommendation that I made before, which is where, you know, I also start like accumulating compile time types that did match, then I can start knocking things off faster and faster until I get to what is essentially the right answer. But again, I only really committed to like the arity shortcut. I didn't commit to accumulating types and like, you know, getting blazingly faster and faster until, you know, I'm running so fast that I hit the right one immediately. Yeah, that's, you know, just the choice that I had to make. So safety. Safety is optional, but not stood optional. We're going to talk about why. Queries can be made safe. So this is a bunch of queries that you can make out of it, right? So you can manipulate the memory directly if you pull out a type and it's like this class type, right? And so if you take a reference or a pointer, we like give you like the memory directly, and if you screw with the memory, like it'll show up in the Lua VM like directly, which is great. You know, you can get functions and you can call, you know, functions, but here's the thing, right? What if value doesn't exist, right, in the Lua VM? What if my object doesn't exist? What if any of this doesn't exist? Then these would be errors, right? These would be pretty. These wouldn't be errors. These would be seg faults, which is terrible. Yeah. So, but here's the thing, right? It's fast if you do it this way, right? You know, we don't bake the safety in because there is a class of people who need that speed. Like the people who do the HPX projects and all that other stuff. They need the speed. They don't want safety baked into all of these queries.
Why are they using Lua then?
Okay, so like these are people who are researchers, right? So they don't want to commit to learning all of C++, and their goal isn't to make good software. The goal is to get their research out the door and publish the papers. So they're going to pick up Lua, they're going to pick up Squirrel, they'll pick up JavaScript, whatever they need to get their job done, right? So it's a matter of throughput and you know, deliverables, right? And that's why they do that. Yes, Jason.
If I can interject on this, the key to using this correctly is to put the time critical stuff in C++, use this for the glue. And you can get very fast throughputs.
Okay.
Yeah. Yes. And so,
Isn't safety just one unlikely branch? So like what would it matter? Why is it so?
So if we were to put safety in there, we would have to do type checks. And so when people use Lua, some people use it as a static library, but a lot of people use it as a dynamic library. So calling Lua functions inserts like a compiler barrier. The compiler can't see before or after that, right? It's a DLL call. So it could have side effects and everything else that it can't quite reason about. So when I just do a simple check for one of these, I'm inserting a hard fence that the compiler can't see through. So there's no optimization around there. If you linked it as a static library and, you know, you did all that, and of course, you know, LTO and then LTO and link time code generation that Visual Studio does and all of that, and yay, it's going to be great. But you know, when I do my benchmarks, I also compile Lua as a DLL because I want it to insert the compile time fence so that, you know, I'm only measuring like the cost of the framework raw, right? So yeah, so these queries can be made safe. That was the point I was trying to make. These queries can totally be made safe by wrapping it in optional. And you'll see here that I use sol optional, not standard optional. I will semi-rant about that later. The reason I do this is because I do my class reference and I want to stick that in my optional. And there's very good reasons as to why I do this, right? So when you ask for a reference, I specifically make sure the thing isn't nil. Nil is this kind of type in Lua that can, you know, just represents emptiness, right? Whereas if you ask for a pointer, if the object is nil, I will hand you nil, right? I'll also hand you null pointer if you did directly serialize a null pointer for my object. So it's about semantics, and it's about, and one of the other things about is about teachability, right? But as you can see here, you can kind of check for, use sol optional to kind of check all of these, right? And because again, we have this system where the check get, and all of that are taking care of everything that's on the left-hand side immediately communicates to the system on the right-hand side, check for safety every time you're diving in to check these things, right? And so you can get engaged and unengaged optionals based on whether the thing actually exists or not. Yes, Jason.
What if they actually exposed an optional into the scripting engine? How can you handle that here?
What do you mean by expose an
Like
option?
if the C++ optional is something that you made a user type.
Okay.
So you've kind of gone around that by having your own full optional.
Sort of right. So the question from Jason was, if I have my own, if the user creates their own optional type or wants to use std optional or as a sole optional, does this kind of prevent them from doing that? And the answer is yes. I had to make a specialization for optional, so it kind of takes the power away from them to make their own like optional thing, right? Or to inject their own semantics. Now they could, of course, it's a header-only library, so they can go in and delete the code and then insert their own thing if they really want to. Or they could, give me an issue request and tell me, this is why I think we should change the semantics of optional. I have over 600 issues and there's only like 4 open. I've closed like everything. I'm very fast at that. So, I'd be more than happy to listen if somebody had like a suggestion about that. But yeah, so this is how you get safety. And so to kind of why standard optional doesn't cut it, for the reference case, I would have to use like a non-null T star struct and put that in the optional in order to get the semantics I want to like not check for, to basically avoid the nil check, right? And avoid the penalty that incurs. GSL non-null is an alias, so it's not actually suitable for this case because it just disappears in the pilot, and so I'm just getting a pointer and now I'm back where I was before, right? And plus the overhead for like making my own non-null struct and then putting it in an optional is like not okay, right? Because I can't specialize standard optional to like behave properly with my non-null. That's like not something I can do. Or I don't want to commit to that because what if they change it and oops, my implementation's out of date. So I'd rather just kind of ship my own optional to get that kind of feeling. Plus there's a lot of people who use boost optional and they try to take it to this framework, and I do have a sole use boost like define that you can do to get boost in here. And so a lot of people expect this to be like a thing that works. And when I used standard optional and I found that it broke and I got like, 3 issue requests in the same day, like why is this busted? I was like, oh, standard optional is terrible. So, it also breaks my library teaching, right? I have one rule. If you want safety, just wrap X in an optional. And that's it, you're done. I don't have to teach you about non-null. I don't have to tell you about any of these other crazy things you can do. You just use it. But if I used that optional, it would be, if you want safety, just wrap X in optional. Unless it's a reference, then you need to use ... we start getting the West Const rules, right? The spiral, right? And then when does it end, So not interested in std optional, totally interested in sol optional. And my fix for this is I am going to fight somebody about this because it was in the paper before and they removed it. I have no idea why they removed it. And I think it was because somebody made a contrived example about assign through for the optional, right? So if you have a sol optional of like int ref and you set it to a variable that exists, right? And then you do, my optional equals 12. Well, somebody's like, oh, well, should that assign through to the thing, right? And so that became like a discussion, and people bike shed about that, and then, rather than finish the bike shed, they was like, we don't have time, and they axed it from the optional paper, which was a really dumb idea. Because if you think about optional and having assign through semantics on a reference type like this, that means that if the optional is unengaged, you have very little choices. You either terminate, you either throw, or you perform some kind of crazy UB. None of those are acceptable, which means that the example that if they had just extended that conversation a little bit more, they would have realized that, and that wouldn't have been an option on the table, and they wouldn't have axed this out of the standard in the first place. But they did. So that's where I am. Yes?
Yeah, could you tell us what you really think?
No, that is what I really think. Optional should rebind, for optional reference, should rebind on assignment. It's the only same behavior. You don't allow R values to be assigned to the optional reference to prevent dangling lifetime issues, and you reduce internal boilerplate code that I and other people would have to do with std optional.
Why you have star on an optional? Like if you want to assign through to the thing, then just star optional.
Right, and that's the thing, right? People they should have had that conversation, but they didn't. That horrible example that somebody posted in like the accumulator or whatever the discussion, they just tripped everybody up and everybody fell down, and that was the end of it.
This is like
Yes.
a continuation of Ben's talk where the operator equals is a problem, right? And a defitted long and a join.
Yeah. On the other hand, Jonathan explained very well about all of these categories of pointers. So
Michael, yes.
the committee should watch that talk.
Yes, Michael.
We probably want to move on. We actually argued about this subject the entire last year.
Oh, okay. Well, then I guess everybody's aware. That's great. Stood promise Sol, or what things are in the future for Sol, basically. So, Sol3 why? I'm going to read you this quick quote. I had spent a whole day for moving my binding from 2 Lua++ to Sol2. I found my Xcode became very lag, and compile time is about 10 minutes, and I use about 8 GB heap, so I have to abandon Xcode for coding. I had spent another whole day for moving my binding from Sol2 to Kaguya, and the compile time is 2 to 3 seconds. I'm ashamed. Right, so it is Xcode's problem, but I have gotten similar reports about this for something like Visual Studio 2015. 2017 doesn't have this problem because they revamped their engine and it's wonderful and it's great. And the only fix for Visual Studio 2015 is you have to like define like if, def, IntelliSense, you know, don't include Sol2 header and if, right? And so that's how that works in 2015. Right. So, but this is what this is why I want to do Sol3, right? And so, because compile times matters. The good thing about variadic templates is they lose absolutely zero information in propagation, right? So I could propagate these things all the way down, right? And I perform some crazy optimizations to make it really fast and to slim down, you know, what's actually gets stored in Lua, right? So if I detect that you pass me a lambda and that lambda is convertible to like a function pointer version of itself, I will serialize the function pointer and not the lambda and throw the lambda away. If you pass me a member function pointer and like and the type that's supposed to bind with it, or the object that's supposed to bind, the self object that's supposed to bind with it, I will take that, put that in a up value for the function, which is like this function local storage, and then use that to call and serialize and call the function. And a lot of things I do like that, right? And if I were to use like type erasure like a lot of other libraries do, I would just kind of drop this performance on the floor and drop the storage on the floor. Yeah. Jason, you had a question-ish?
Well, I was just thinking about your notion of dropping the lambda and just going with the function pointer version of it.
Yes.
And I have chosen to not do that because I thought that would lose an optimization possibility would be lost by the compiler further down when you actually go to execute the lambda, but I don't know if it's actually true. I never tested that.
Well, the thing is, right, so when you serialize, I mean, it might be different like ChaiScript and other things, right, because of the system it's in, but for Lua, every single function gets serialized as what's called a Lua C function, which has a fixed signature. So everything takes this kind of barrier on it, right? So the compiler can't optimize through that in the first place, right? Because the Lua C function gets stuffed in Lua, and that goes through some inscrutable system that the compiler can't completely see through. So when you get it out on the other side, right, you're better off having the function pointer than having to have to do the right thing, right, where you serialize that to a full user data and then pull that user data out and then get that user data and then finally call the lambda, right? So it's a matter of space and speed in that case, right? But for something like ChaiScript, where like the engine is built in C++ and it understands some of these things, you can save that information directly and you'll get all the savings, right? So does that make sense?
It may, yeah. I mean, I believe everything you said. I just don't.
The thing is, while you're going through some dynamic thing, you have to have a function pointer somehow.
Mm-hmm.
So if that function pointer is being represented directly, that's better than having
like a void pointer
plus some other stuff.
Yeah, having like a void pointer off to the lambda that you like allocate and keep and all that stuff, right?
You might be able to do that.
Right.
Yeah, okay, that would definitely be off topic, I think, from where you.
Yeah, but it's still interesting to know. So yeah, compile times matter. And so I actually there was actually a small case study I did with this, right? So I have another function called create enumeration, right? Where you pass it like, name, you pass like name, value, right? And you create your own enumeration. And that was a variadic template too. Somebody created a very big enumeration and they passed it this thing in the compile time. I didn't put it in a tuple, but it was still like huge. And so what I did is I bit the bullet, and so I said, if you pass me something that's convertible to a string view of plus the enumeration type as like a pair, I will use the initializer list. And so people started using that, and the compile times went way down. And the performance was the same. It was the same because I ended up serializing into Lua, and it was just the string name plus the value. And so there's some potential here for me using initializer list to do something. And I've got some really crazy ideas that I don't think I will have time to talk about, or I might be able to talk about in like questions and whatnot. But I do have to save the compiler performance. It is a must. And I will bleed users without it. And I don't want to, even though I have 1,000 stars in it, and so it's wildly successful and it's used in industry and stuff like that, I don't want to bleed users that are very conscious of the build debug cycle that I have, which is very popular in game development, right? I can't forsake those people just in the name of, maximum variadic template, super tuple craziness speed, So I have to remember those people, and I have quite a few ideas about how I would do this, and Kay Ballo or Augustine has actually given me quite a few ideas on how I would do this and not lose performance. Yes?
Have you tried benchmarking using a different metaprogramming library? Because Odin is like blazingly fast.
So I haven't done that because I was trying to avoid taking additional dependencies, right? I remember at one point optional was like a dependency that was like in a submodule in my library, and that was like too much for people. Yeah. Like they like complained like why are you so I mean the way I solved it was I built it into Sol, right, and so that became a problem. So if I take like Odin's library and I like cram it into my thing, then yeah, it'd be great. But
Big super header.
yeah.
If you were to build your own, I don't know how much of that compile time is tuples, but if you build your own primitive tuple, it can be like 100x faster to compile than a standard performing one. There are like, if you get really Machiavellian, you can break it easier than you can break the standard library, but if it's all internal to your library, just a struct that derived from a variadic pack of tagged structs, not a problem, right? It can even still be const expert, it can even still be like a lot of that stuff. Just, for example, the use case where you want to construct it from a pack of elements that are not as long as the entire length of the tuple, and you want the rest of them to be default constructed, that probably won't be supported, right?
Right.
But if you lock off a lot of the really, really compile time heavy stuff, you can save a lot. On your own tuple.
So you wouldn't have to figure out which constructors are explicit and which ones aren't. You could just make them
exactly.
Right. So yeah. To repeat for people watching the video, you can save a lot of performance if you don't need like a fully standards conforming tuple with explicit constructors and const expert and all that other fun stuff. You can create your own tuple that's just derives from a tag of bunch of tagged structs, and you'll get crazy performance. So that's actually something I might look into. I was actually looking into just throwing out the tuple altogether and using a std vector of std byte, and then creating another std vector of like type erase things, and then like stuffing the things in the std vector. It was a crazy idea.
You know all that stuff at compile time still, right?
Yeah, I'll know all that stuff at compile time, right? So
yes, you want to use const expert to build those tables instead. You could get everything you want and the performance for it.
All right, so Jason made the point that I could build those tables myself and get a lot of the same performance, and so I definitely have to look into that. These are all things again I'm looking into for Sol3 to change the interface, the API a little bit, and get some of those performance back. One of the other things that I can do is use if const expert. The problem is that it'll lop off everybody. GCC 7 or GCC 6 and below, I'll lose those users. Clang 3.9 and below, I'll lose those users, which that isn't much of a problem. But I also lose everybody below Visual Studio 2017. So 2015 and below, I'll lose all those users if I use this. But I did some basic testing. And so I have one of these really gnarly, like, for serialization of functions, I have a tag dispatching SFINA, like 12 overloads, and then like some extra stuff, right? It's very gnarly. It's very disgusting, and it caused a lot of compile time crunch. And I tested by moving all that tag dispatching into like 3 functions with like, just if const expert, and compile times went, and they didn't go through the roof, they went down. They did not go through, they went through the floor. And so this has a lot of things that I really want to look into as far as using if const expert to kind of clean the performance a little bit. So yeah, this is one of the things I want to look into. I also want to use the binary bloating McBloatface. So I have a lot of like temporary functions because this was kind of from the legacy of like working with C++11. And when I say C++11, I mean like C++07. That was like what Visual Studio had at the time. I want to use, I have like a bunch of like functions that just like do this one very specific thing, and it's like I create this whole function that has all these templates in it just to do this one very small thing that I could probably do better with const expert or something else, right? So I want to use the Google's binary bloated McBloatface to help tell me, where a lot of these instantiations and functions are coming, so I can start slimming down binary size. Because another complaint is that my binary sizes are, huge because they do all this thing. Now, if you use a release mode, it can trim out a lot of it, but some of it stuff it can't because, I don't put in anonymous namespaces, so it can't prove that's only used like once or whatever. So this is what I need to use because it's definitely enormous. I took a look once and it was not cool. But the goal was runtime speed, right? So, I failed at compile time speeds when I made Sol2, right? But did I get runtime speeds, right? So let's figure that out. That's you know, it's all that matters, right? So these are benchmarks that I wrote. I'm going to increase the size. There we go. I mean, you don't have to read all that. That's just like me explaining the benchmarks and what I did and where you can find them. I actually made a new set of benchmarks that include more libraries in this. So right now I'm doing like 1, 2, 3, 4, 5, 6, 7. I do like 13 libraries right now. So the next iteration of this, I'm benchmarking against 16 different libraries. So I take it very seriously that I'm on the top of this list. I need to be on the top of this list, right? Because if I'm not, then what was the point, right? I need to prove that I have very little or almost no overhead compared to plain C. So this is for member function calls, right? So you can see the old Sol, the Sol1 made by Wraps and that I worked on a little bit. Yeah, we were terrible. Swig is right up there with everybody else. Lua Intef is another one, Lua Wrapper, and so we kind of go all the way down, right? Lua Bind is actually pretty decent, but one of the faster ones is Lura, the new Sol, OO Lua, because it has a macro-based DSL, so it does macros and they use templates behind those macros. So it's a little bit difficult to use and it lacks some functionality, but it's fast. That's the point, right? So member function calls are fast for Sol. User data variable access. So the reason why half of these things show up as unsupported is that when you try to bind a member variable, it just turns it into a function in Lua. So you can't call it with like object.a. You have to do object:(a) parentheses, to get the call. So, if you're just starting out, you don't really care what syntax you get, right? But if you have a very large Lua code base and you want to, have member variables and you want to act like the tables that you've been using all this time, that becomes unacceptable, right? So this is why this is set. These are all set as unsupported, right? So as you can see here, old Sol is blazingly fast with user data variable access, and I know this because I did lots of optimizations to make that happen. So we're basically the same as we were before, which is great. Many user data variable access. So what this tests is how good is your search, right? So if I bind 50 member variables and I start calling them in random orders, right? It's a fixed order, it's a random order, but it's fixed for the entirety of the benchmark. So everybody accesses everything in the same lookup order, right? So it's all fair across things. How badly do you suffer? And you can see here, Lua Intef tanks pretty hard. Lua Wrapper and all these kind of tank really hard. And we're still up here, right? But plain C, man, when I implement the plain C, I had the privilege of being able to directly, because, with plain C, I basically implement it as if I was trying to do the fastest thing possible, right? So I get to do all the, I don't have the same constraints as I do when I use Sol, when I have Sol2 and I have this runtime system that I'm trying to manage, right? I just know exactly what I want to call. I do, I just create a perfect hash map and then bam, that's it, right? If I could figure out how to get a more perfect hash map for Sol, I'd be able to reduce this at least a little bit. Though there were some improvements that were actually done after this benchmark was computed, where if I use boost, so if you use boost and you say Sol use boost, when you look up member variables and user data variables, there is a zero overhead, there's a zero allocation, zero overhead path because boost maps support using a different key and a different hash. So I can pull out a string view, instead of serializing it into a string and then having to perform the lookup to do all of this, I can pull out a string view and say, listen, this string view and this hash function, this equality function are all compatible with the one that's in my map. So just use these to hash and compare and everything's going to be fine, right? And so I get a zero allocation, zero overhead path. And the reason I found this out was because somebody put an issue open against my library saying, hey, I use this in a critical audio thread. I'm noticing some allocations. I like that to stop. And so I said, well, if you use boost and you do this, and I went through, I used Sol, I have a defined Sol compatible unordered hash or whatever. And if you turn that on, then I don't do any allocations. So that might actually affect this benchmark a little bit. We might get a little bit faster and get a little bit closer to plain C, which would be fantastic. Because plain C stores everything as const char star because it can, because it's C. It knows that the memory is going to stay there and I don't have to do anything about it, right? Some other things. C function through Lua, right? So if you bind a CS+ function into some F, right, in Lua, and then you try to call that function through Lua, what is the performance overhead? I don't know what Lua CPP interface is doing here. I didn't step through their code. I have no idea what's going on. But the rest of us, we're all doing pretty great. And again, you can see the error bars here, which represent the standard deviation. And the scatter plot here just kind of shows you the individual samples, right? So you kind of always get a full picture of what's going on. And And so you can see, we're extremely competitive here, right? And I mean, even though theoretically we're faster than plain C by the median or the mean, it's within the error bar, right? It's not a big deal. Stateful C functions. This is when you create a lambda and you put stuff in that lambda, so you can't do the function pointer like convertibility thing, right? So you have to serialize it as stateful. Some things fall down on their face when you try to do that, like Lua and Lua CP interface and Lua API PP, because they have macros and other stuff that try to do it for you. Lua is not having a good time here, but the rest of us are having a good time, and Sol's again up top there, which is great. This one confused me a little bit though, because there seems to be a non-negligible performance difference here, and this confuses me. I think I actually solved it in my latest series of benchmarks about what was going on. So the numbers will be better, but we're all basically down here. That's all you need to know, right? And so this is for just calling a C function directly, and this is pretty good performance. Calling a Lua function inside C++, so you get an abstraction for Lua function, you call it. What does that look like here? The reason old Sol and Sol get boosts here is because we have an abstraction that allows you to preemptively push the function onto the stack, and then you can do a bunch of function calls and work with it, and then you can pop it off later. So plain C and a bunch of these other things, you have to get the type, and then you call it, and then you pop it off the stack, right? And then so it's to clean the stack nicely, right? So I might implement the same thing for plain C because it's plain C and it can do everything that the other things are doing, and so it feels a little bit dishonest to have it doing that, right? So I don't know, bump it up and make it like the others. But Swig is actually ridiculously fast. This is the first time Swig is actually showing up to play. It's great. They're doing a really good job here. Their function abstractions are really good. I actually learned a couple things or two by looking at the vomit of generated code they spit out here. Whoops, that was not what I wanted. Absolutely unreadable. It took me forever. Yeah, I have no idea how I did that. So we're just going to continue on. All right, multi-return, right? So this is where you try to serialize multiple things back into C++. A lot of things don't support it. Luabind, though, down here, Luabind actually does support it, but Luabind, the library itself, has died, and Rasterbar, the subsite, is gone, and the people who vend Luabind are gone. So the only remaining version of Luabind that's actually mildly kept up to date is Luabind deboostified by somebody who forked basically the library and is working on it on his own. And he decided to kind of gut support for that. I don't know why. He just said, I'm not interested, and that was the end of that. So yeah, Luabind does have support for vanilla Luabind, but you can't get vanilla Luabind anymore. So that's the end of that. Global get, right? So this is what I was talking about, where depending on how you use the Lua get global versus Lua get table and get field and all that stuff, right? The difference, right? You can see it here. Selene is tanking, Luabind is tanking, even Lua CP interface has a large amount of overhead, right? Compared to everybody else who uses the get global version, we're all very fast, right? So this is one of those API traps, right? So that's what that is about. And so yeah, there's more benchmarks, and it's on the web, you can view them, and that's all great and all that stuff. So now let's just continue on. Last and most important thing, I have 20 seconds, so I'm going to totally tell you this super important thing, I swear. Documentation, oh my God. Greetings, I used to use Sol, but I could not figure out how it works, and thus quickly switched over to Selene, which you saw had terrible performance, but he still used it anyway. Since on its main page it had a much better tutorial how-to manual. Documentation is awesome. You will bleed users if you don't have documentation. You need to have documentation, get documentation, it's really great. Benchmarking those libraries was hell because so many of them didn't have documentation. So I'm trying to figure out why is your performance terrible, and I just can't figure it out because they didn't document anything. So I have to get a debugger, and I have to step through their code and be oh, this is what they're doing. Oh wait, no, that's not what they're doing in this case. And documentation. It's very good. Get it. It's great. I didn't have any, and I lost users and everything. And he says, I think Sol has more features. It totally has more features, but I didn't let anyone know it had more features, so I just lost users. The backbone of any product is your documentation. People, some products are the only alternative, right? So the only product that does X. So people will muck through its APIs and class APIs and join IRC and do whatever it takes to understand it. But Sol2 has 20 plus competitors all doing their own bindings. I can't afford to no documentation, that's fine, right? It doesn't work that way. Gotta have the docs. Gotta have the docs, they're necessary. And we do have the docs, and they're beautiful. We have over 100 samples, everything, all 100 plus samples and 50 plus examples and all that stuff, all of that stuff gets compiled as CI, and so every single sample that you see on the web page is compiled, and it works, and it runs. It's great. Have documentation. It's wonderful. All right, so a little bit of thanks and chilling. I guess I'm sort of biting into your guys' time, your break time a little bit, but I need to thank a few people. Support me and my family. There's a donation link at the bottom of the docs and then the README. Donations actually kept me fed for this trip. So thank you to all the people who've donated. Robert, Russian person's name I can't pronounce, but his online handle is Orpheus Z. Michael Waller, Elias Dallaire, and Johannes Schultz. What?
Orpheus.
Oh.
I mean, Cyrillic does look like Greek, so it's okay.
Yeah, but he's Russian though. How did he get a?
That's definitely not Cyrillic.
I mean, he comes to my he comes to the Discord often, so I'll totally ask him how he ended up with a Greek name, because he's Russian, he's in Russia, he's working from Russia. How did that happen? I'll have to ask him. My gratitude to Mark Zarin, who's here, Simon Brand, who's not here. They actually pushed me to apply as a student volunteer in the first place. I wasn't going to be here. I had no intention of showing up. I wasn't going to. I think a long time ago I applied to CPCon and it didn't work out because I was doing weird things. I wanted to apply under my alias name only, and they were like, "Be professional, get out of here." So that didn't quite work out, and so I was like, I only want to be the PhD anywhere. I don't think I'll apply, and so I didn't. But Mark Zarin and Simon Brand both kind of talked to me a little bit and said, "Listen, you should apply," and they gave me words of encouragement, and those things are powerful. They really do help people like me. Kind of put our foot out there again. Also, Jason Turner, who's also here at Lefticus, he spoke about Sol before I even ever had plans about like showing it to the world. Like he presented it somewhere, I believe at here last year. So 2 years ago, and he presented about it, and like sol2's popularity like exploded overnight. I had no idea why this happened. And then like later on, like somebody came around and I was like, "Oh yeah, did you know Jason Turner talking about it?" I was like, "What?" And I found his presentation. I was like, "Oh my God, he actually praised sol2. Oh my God, this can't be a toy project anymore. I'm responsible now." So he also really encouraged me to speak, and I finally got to meet him here, and it was wonderful and great. And I'm going to appear on CVPcast on Monday, May 21st. Permitting no hurricanes, tornadoes, or anything happen. I'm going to be on CVPcast, and I guess I'll talk more about sol2 and the journey and all that fun stuff. More gratitude. Hipponi, who's on the CFP Link Slack, and Kaizo also helped me bike shed the new logo that you saw at the very beginning, that shiny new yellow logo with the S-looking thing. I also want to thank #include, because they also kind of generally kind of supported me in kind of getting places and really opened my eyes to like that I wasn't the only one who kind of had these experiences where I felt like I was like the only alone and I was the only one, right? So just sharing and being able for them to kind of assure me that, even if I am different, that they will still accept me as just a human being and judge me on those merits is a very refreshing thing when you kind of grow up the way I did. I also want to thank the Lambda C++, for always dragging me back onto this wonderful couch. And being amazing nerds with great sense of humor and all that stuff. The guys have been really, really great. So any questions, comments? This is my email, my Twitter, LinkedIn. Actually, you should totally go to that LinkedIn. I actually got the link, the PhD. You can find me on LinkedIn by saying /in/the PhD. It's great. Yeah, so that's the talk. Thank you. Any actual questions, or did I totally answer them? Oh, yes.
You said like the backbone of the API is this reference concept.
Yes.
And with user types and user data, it would be difficult. But is there a way in your library to actually serialize and deserialize things? And the reason I ask is one of the things that I like about Lua is everything's in the Lua state. So
right.
You have some like super multi-threaded event processor thing, each with its own interpreter.
Right.
And they can send messages to each other. How would I do that?
So we don't. The serialization is through like the get and set and all that stuff. That's how you get the structs in and out. We don't actually put it in like binary format, so we don't have like JSON serialization or anything. But Elias Dallaire made something called meta stuff, and he put like JSON serialization on top of sol2, and it wasn't like he came to me and it was like, "This is a lot easier than I thought it would be." And I was like, "Yeah, that's the point." So it's possible, right? You can package things and ship them off to other places, right? It's not You can do it if you have access to the full C++ system. You can do that just by using the getters and setters and kind of ship them between each other, or you can kind of serialize this into this format and then pipe it across, a named pipe or whatever else is you're using to communicate between systems. But yeah, that's like totally supported scenario. You're not going to have it's not going to be a hell of a time. We don't have like a deserialize all function, right? We don't have that built in, but we have all the utilities to make that happen for you.
One more question.
Yes.
Was that GNU plot that had those bar charts?
No, that was a GNU plot. So that was actually matplotlib. So I used a benchmarking framework called Nunius, and Nunius actually has its own HTML charts, but I didn't quite like them because they didn't do, they didn't do like the fancy scatter plot with the error bar and all that fun stuff. So I actually have an even better version. You guys mind sticking around? I can show you. Yeah. So I can totally show you the. Okay, so this is actually going to be my super secret blog. Like, don't tell anyone that this is like a thing yet.
It's on YouTube.
Oh. Well, whatever. I mean, by the time the video, if my blog is not ready by the time the video goes out, I failed. I failed miserably. I have no idea if it's so github.io, and I can't tell if that's the right URL. I totally can. So this is actually my blog. I'm working on it. Name pending. I'm working on it. But if I go all the way down here, for the case for pointer in the shared library, so this is actually another paper I want to write that Mark Zarin actually inspired me to do. I have shinier, more well-improved graphs, right? So these ones I actually made, these ones are actually colorblind friendly, right? So in the hashtag, and this is why I like hashtag include, right? So I went to the hashtag include and I posted like early versions of this, and they were like, this is a garbage graph if someone's colorblind. And I was like, probably right. And I was like, well, I wish there was somebody colorblind here who could help me. And then the person who was like there was like, hi, I'm colorblind. And they helped me develop this, right? So there's like swatches, and it patterns the thing and the colors, and it shows all the same stuff. So the graphs are actually going to look a lot prettier when I get the updated going. I did finish doing all the benchmarking. It's just that I have to like remap the tools a little bit to print these prettier graphs for all 16 frameworks. I'm never going to do that again. Yeah. So and again, it was thanks to the hashtag include Discord, Software Bear and Seth and a bunch of other people who really helped me bike shed and make these kind of really pretty graphs. Yeah. All with matplotlib, right, in Python. And the code is going to be open source. So if you want to look at what I do, all the code is open source. Sol2, the old benchmarks library is open source, and the new benchmark library is also already open source. I just need to push the Python changes. Yeah. Yes.
Sorry, which license?
MIT. It's all under MIT, but I'm considering changing it. Not to anything like commercial or anything, but so I've heard of people who have MIT licensed software, and they accept pull requests from people, right, into their MIT licensed project. MIT license has no guarantees to protect you from people who push patented code into your thing. And if you're not smart enough to catch it, and somebody creates a binary out of that, that person can be sued. And that person was sued, and they got screwed by a patent troll, basically. The software, the license that can protect you. So this isn't. It's not a bad thing for like a corporation, right? And I've had very few pull requests, and I've guarded the code, and I've verified it's all mine. It's MIT, great. But the other license that will protect you from this is the Apache license. Any contribution that's made to you deprives the person who made the contribution the ability of claiming copyright or anything like that, right? So it becomes part of your library formally. And so Apache 2 helps you do that. There might be a couple other library licenses that help you do that. But yeah, just something to keep in mind about the MIT library. I still use MIT because I'm pretty judicious about what code I accept and everything else, right? But just keep that in mind. Yeah. Any other questions? All right. Okay. Well, thank you.